So here I have the write-up and the practical values for what experiment I have done for your glass slab experiment. So what is the main aim? To understand the phenomena of refraction through a glass slab. So what and all do we need? Obviously a rectangular glass slab, 4 identical pins, which I have not used. I have used different pins, different length, that is, white paper, pencil, scale, protractor, right? This is your ray diagram or the setup. Basically this is how it looks. Then we have the procedure. So with respect to this procedure, I have labeled things over here. Okay, so the procedure is the same thing what we did. So take a white sheet of paper, place a rectangular glass slab, mark the boundary. So remove the glass slab, draw a thin line XO, that is your incident ray, and the angle should be around 30 to 60. It's not a rule, it's convenience. Then again replace the glass slab exactly where it was, fix pin P1 and P2. I first fix the pins and then I put the glass slab back. The order doesn't matter. Then observe the pin P1 and P2 through the face BC. Okay, so I hope I've named it. Okay, no, this is DC. So I have to change this. So this will be A, B, C, D. Okay, this I missed. A, B, C, and this is D. So we need to observe pin P1, P2 through the face BC. So BC is from this end, right? So we need to observe from here. While observing the pin through the face BC of the glass slab, fix 2 more pins P3 and P4 such that the feet of all the pins appear to be in a straight line, so that they are collinear basically. So P3 and P4 should be collinear through the glass slab. Okay, obviously it's not collinear when you look from above, but through the glass slab they look to be collinear. Then remove the pin and mark the things and join the lines and so on and so forth, and record the angle of incidence, refraction and emergence. Repeat the experiment for another set of values. Okay, so like that we can do 3 times. 1, 2, 3. I have shown you guys once. I have done 2 times, which is relevant to this particular thing. So they are this. Okay, right? So this is your first one and the second one. So let's look at the angles. So here I have supposed to be 40, but I missed it. So this is 10, 20, 30, 40, 42. Okay, so here the angle of incidence is 42. So this is 42 degree. And angle of emergence, it's around 40. So approximately 40. So I missed by an angle of 2 degrees. Sorry, that is angle of refraction. Okay, at this point we are measuring angle of refraction. If you guys are not able to see that, let me show it to you this way, right? So this is 42 and this is 40. Now here also I will measure the angle of incidence and refraction. So angle of incidence with respect to the normal, right? 10, 20, this is 25, and this happens to be, oh wait, this not supposed to be 40. I think I measured it wrong. 10, 20, this is 25. Sorry, why am I written 40? This is clearly 25. This is 10, 12 to 13. So I'll take 13. Okay, next value. Next, emergence is over here. So this is around 39, right? So angle of emergence is over here. I'll show you, don't worry. So this is where we are measuring. This is 39 degree. If you're not able to make out where exactly things are being measured, I'll repeat this, all of it again. So this is around, not very clear, 23, I guess. This also I missed a bit, 23 or 24. Not exactly, not able to make out actually. Okay, let me do one thing. Right, I can do that. Okay, so not an issue. So this is around 24, right? I missed by a degree of 1. Okay, wrong place. This is 24 degree. So let me show you guys removing the protractor, right? So these are the angles which I measured. Okay, so I had a 360 degree protractor over here and a 360 protractor over here, right? Here to 360 degrees, 360 degree. So I'll try to make this available online so that you guys can take a print out and measure the angles. Actually, more than that, I want you guys to do it. The entire thing, I want you guys to do it. Then taking a print and all of that, that doesn't make sense. What's the point of trying to prove if I'm right or wrong, right? You guys learning is what is important. So yes, this you guys have to make a note. Actually, even I have to make a note. So the first one, we have angle of incidence to be 42, refraction to be 25, and this is 39. And for the second one, we have 25, 13, and 24. Okay. So I have a small margin of error. Again, this is all human error. That's okay. Okay, all this I have to. Oh yeah, marking was here only. So let's fill in this blank. So the first, second, and third. So the first one is angle of incidence is 42. Not a good color. This is not a good color again. 42 degree, right? Then refraction is 25 degree, 39 degree. So difference between them happens to be 3. That's a lot. And over here is 25 degree, 13 degree, and 24 degree. Difference is 1. That's good. I'm just assuming and writing 60 degree. This I can't assume and tell. This I'll tell 61 degree, and 1 degree. I could have done one more. I don't know, I'm feeling lazy. So what can we conclude from all of this? The angle of incidence and the angle of emergence are equal, ignoring the human error, right? They're approximately equal. As angle of incidence is equal to angle of emergence, the emergent ray, emerging out of the rectangle glass slab, is parallel but laterally displaced with respect to the incident ray. This is what the whole idea is about. This is what we have to observe. The angle of refraction is lesser than angle of incidence. In each case, the ray entering from air to glass bent towards the normal, right? And so this is your conclusion. So it will bend towards the normal since it's moving from rarer to denser. The angle of refraction increases with increase in angle of incidence. Yes, that is true. If I happen to increase this value increases, right? And yes, angle of emergence, angle of incidence, and angle of refraction. So these are your writing. So these two values have to be same. Of course, you'll get a small error, kind of. If you do it right, you almost don't get an error. 1-2 degrees okay, 3 degrees a bit. I think I was trying to hold a phone or something, trying to take a video or something. So I've done some stupidity. That's okay. Plus, human error happens. Right? I know it's a lot to write. So depending on what you guys have exactly in your syllabus, okay, if there's a possibility that you will get such an question, you guys have to write it. It's not too hard. It's lengthy though, right? So please pause and copy it off.